Okay, people had requested that I make another video going over more examples of percent applications, so I'm just going to make up a few more here. And maybe I looked at all the problems you're doing on that worksheet, and I'll try to make some that are more similar to the problems you're solving. So first off, say we have this. Let's see. I go out to eat with 3 friends. Our meal costs $37.50. We want to leave a 15% tip and we pay equally. How much does each person pay? And one thing I will point out, as far as it goes, and you can see this on the worksheet you're doing, there are problems similar to this, but the problems in the worksheet are kind of broken up into parts. Part A, Part B, Part C, Part D. And sometimes problems are written that way. Other times, you're just kind of given one statement, and the assumption is you can understand what the problem is asking and understand everything you need to do to ultimately arrive at the final answer. How much does each person pay? So me and my friends go out to eat. The meal costs $37.50, but we also want to leave a tip. And then we have to figure out how much each of us are gonna pay. But that's based off of the total price of the meal. In order to find the total price of the meal, we have to have the amount plus the tip. In order to find the tip, we know how it works. A 15% tip just means I tip 15% of my meal, which means I just need to find 15% of that. Well, how do I do that? Proportion. I set it up. This is always 100. I want 15%. I'm looking for the 15%, so I put an X where the 15 is. $37.50 is the total cost of the meal, so that goes with 100. If I cross multiply, I get 100x equals, button pushing time, $37.50 times 15 equals 562.5. Now we know how to do this. I divide by 100 on both sides. X is equal to 563. We'll round it. I'll do it this way, just so you can see on the calculator. It's 5.625, but this is money, so I have to round the second decimal place to change. So I'll round up to 563. Now there's my tip. So now, what's the total cost of the meal? It's the price of the meal plus the tip I'm giving. So now I add those together. $37.50 plus 563. 3, 11, 13, 4. $43.13 is the total cost for meal plus tip. For those of you who might be thinking, what about tax? I'm assuming the tax is included there. Don't worry about that. Okay. Now, how much does each person pay? Well, that's the total cost. How many of us are there? There's me and 3 friends, 4 people total. So I take the total cost and I divide it by 4. And I get, just to save time here, 43.15 divided by 4 equals 10. It's 7875, but again, it's money, so I'm going to round that. So we'll say 1079. And that's how much each person pays. And again, the point here is from the version of, say, the problems you're doing on that worksheet that you're going through, I think it actually breaks it up into multiple parts. What's the tip? What's the total cost? Now how much does each person pay? And sometimes problems are written that way. Other times it's just one statement, and the assumption is you understand. Do this, then do this, then do this. That's my final answer. And if we think about it, does it make sense? Yeah, 4 of us go out to eat. The meal costs about $40. We each pay $10. That's logical. Okay? How about this? I buy a TV for $349.99. Sales tax is 7.25%. What is the total cost of the TV? And again, we think about it. Well, okay, where does the total cost of the TV come from? There's the price of the TV, but I know I have to pay sales tax. The total price is going to be the price of the TV plus the sales tax, which means I have to find the sales tax. How do I find the sales tax? It's 7.25% of that, which means I just need to do another proportion. We mentioned in one of the other videos, all things being equal, proportions solve a lot of problems in this class. So, put 100 there, that's the percentage, so 7.25. I'm looking for the tax, the 7.25, so the X goes on top. $349.99 goes on the bottom. Cross multiply, X times 100 is 100X, equals, calculator says, $349.99 times 7.25 equals 2537.4275. And I'm aware this is going to be rounded, but just so you can see exactly what your calculator should be saying, we'll deal with the rounding after. Now to get the X by itself, I divide by 100, and I get, I only divided by 10, so bear with me 1 second. There we go. 25.374275. I wrote it right, good. We know this is money, so I'm going to round the second decimal place. The next one's a 4, so I round down. And I get 25.37. And one thing I would point out, you actually could have rounded this one right here just to make the number shorter, and then you wouldn't have had to worry about it as much here. The reason I'm deliberately not doing that, from a math perspective, the more you round and the earlier you round in a problem, the more error you end up getting. Here it might only change it by a cent or two, but generally we prefer to round at the end of the problem. From a math perspective, it reduces the amount of error in your answer. But anyway, this is my tax. And again, think about it from a real world perspective. I buy something that costs $350, there's $25 of tax. Yeah, that sounds reasonable. So now, what's my total cost? Well, let's see. I take the original price, $349.99, and I add on the tax, $25.37, 16, 13, 15, 7, $375.36. And again, like I said, I buy something for $350, I pay $375, yeah, because the difference is tax. That's logical. One more, maybe slightly differently. How about this? A TV costs $750. It is on sale for $200 less. What percentage is the sale? And just so we're clear, essentially what I mean is, I used to work in a department store a long time ago when I was a teenager in college and all that. When you have a sale in a store, there's kind of two ways you do them. One way is to say, this TV is $200 off. Sounds really cool, you're saving $200. The other way to say it is, everything in the store is 10% off, or 15% off, or 20% off. They mean the exact same thing, it's just kind of what sounds better from a perspective of we want to convince people to buy this. So for this, I told you how much the discount was. I want to know what percentage that actually is. So what do? Well, I'm clearly talking about a percentage. If we're talking about percentages, well, we're talking about proportions. So I set up my proportion. I know this is 100. I know the percentage goes here. Normally I'm given a percentage and I stick it in there. Here I'm actually looking for the percentage, which tells me I have to put an X there, because that's what I'm looking for. Now I need to fill in this side, but we know how it works. This has to be the total. Well, the total is the original price before it changes, so that's got to be 750. And now this number should agree with this number. It should be the percentage. Well, yeah, because that's the discount. That's how much the price is reduced, which is the percentage off. So 200 goes there. Makes sense. Now I cross multiply 750 times X is 750X. 200 times 100 is 20,000. Now divide by 750. And I get X equals 26.666, etc., which is 26.7%, we'll say. And again, from the perspective of I work in a department store, what sounds better? Our TV is $200 off, or our TV is 26.7% off? That sounds a little bit weird. It's not a round number. So it makes more sense to do it that way, which from the store's perspective is what you would do. Keep in mind, just really quickly to kind of rewrite this problem, we could say it is on sale for $550. What percentage is the sale? The setup would be the same, where we would say, oh, I'm looking for a percentage, do a proportion. I'm still looking for the percentage, that's X. This is still the original price, which is $750. But now this is slightly different, because if this says $550, that is not the percentage. That's the final price. The percentage is the difference, the change. We talked about percent change in one of the other videos. We're looking for that change, which means if the problem's written this way, I have to say, to get the percentage, I need the change. I need to do the change here. So I would have to subtract 750 minus 550, which is 200. Oh, that's my change. I put that in there. Now I cross multiply, solve, and all of that. And again, the point being, there are myriad ways to actually write these problems out. There's lots of words in the English language. So there's lots of ways to write these, and you just kind of have to get used to reading them, thinking about what the question is asking, and say, okay, I'm at point A, this is point B. What do I need to do to get from here to here? Sometimes, like in the handout, things will be broken up into parts. Part A, part B, part C, part D, part E, to give you an idea. Do this, then do this, then do this, then do this. Ultimately, all of those will be combined into one problem, like the other one we did with the people going out to eat, and you need to be able to see all those parts individually. And again, if you need more videos with other practice problems and other types of things that we've done, feel free to let me know. I have no problem making these things and throwing them up on Blackboard for you.